All right, so let's take a look at deriving exponential functions. And if you look here, I'm going to show you a little small demo in the box here. If we have some exponential function, for example, e to the power of the x, every exponential function is actually a chain rule. So you can see by the definition on the formula booklet that the derivative of e to the x is e to the x, but it's actually, if we derive this exponential function here, what we have to make sure is that inside this argument of my exponential, I call it the argument, that block there, every time we derive, we must first of all write out our e to the power of whatever is in that block here. And afterwards, we're going to chain it onto or multiply it by the derivative of this block. So this block here, if I do that, the derivative of is just 1. So it makes sense that if I derive e to the x, I just get e to the x, all right? So every time, so you have to consider this block here, we want to derive that. So if we were to write it something like this instead, f of x is equal to e to the some function g of x, we could take it into consideration that if I derive this, it's like saying e to the power of this function, whatever that function is, some sort of values of x, times by the derivative of what is in that exponent piece, all right? So let's try a few demos here. So I'll try with number A. This is from the Hayes book. So if I have e to the 4x, well, if I derive this, I'm going to get e to the 4x. So I don't change this 4x, but then I got to chain that onto the derivative of 4x, and the derivative of 4x is just 4. So we're done. And eventually, most likely, you'll put this 4 back in front here because it looks a little bit better. Okay, so let's try B here. Well, if we derive e to the x, we get e to the x, as we know. And then if we derive 3, that goes to 0. So this is quite a simple one. That's all we have to do for this one. All right, let's try C. I have negative 2x as my block. So if I derive e to the negative 2x, I get e to the negative 2x. And then I have to chain that onto the derivative of this block here. And the derivative of negative 2x is negative 2. And I'm done. And for this fourth one here, I have e to the x over 2. So if you want, it's like saying e to the 1/2 x. Maybe it's easier to work with there. And if I derive that, I get e to the 1/2 x. So I don't change this block as I pointed out. But then I have to chain that onto the derivative of 1/2 x, which is 1/2. So there I go. So these here are all my answers, my final answers here, 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 and of course here. Okay. So let's take a look at these two. I'm going to give you 2 examples. And now these ones here, we're going to use the product rule and the chain rule to derive. So if I take, for example, this here, and I say my x cubed is f, and my e to the minus x is g, it's like 2 functions multiplying each other. And that's how I can use my product rule. So the product rule goes as this. You take the derivative of the first times the second plus the derivative of the second times the first. So that is exactly what this law here says, but in a different notation. So let's try this out. The derivative of f, which is my x cubed, is 3x squared, times by g, which is e to the minus x, so I don't change that. I have that. Now I'm adding that onto the derivative of g. So if we derive e to the negative x, we have e to the negative x. And it's a chain rule, so we have to derive this negative x, which gives us negative 1. And of course, it's going to be g derivative times by f. And our f in this case is x cubed. So there we go. We have this whole thing. And of course, you can clean it up. Maybe you want to take this -1 and switch the sign out front so it's negative. So you get rid of that. Notice that there's an x squared in common on both of these terms. So maybe we want to factor out an x squared. So we have 3e to the negative x. Subtract e to the negative x. In this case, there's x cubed there, so now we only have x. So once in a while, the IB asks you to show that question. So here's an example of a show that question. Okay, so there's a product rule using exponentials. And now, if we look at this last example, this is a quotient rule in which the top, we can call that the top f and the bottom g. And then our quotient rule says the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. Not the derivative of the bottom squared, just the bottom squared. So if we use this notation and begin deriving, let's see if e to the x is my top. So the derivative of the top, so the derivative of e to the x is just e to the x times the bottom, which is x, minus the derivative of the bottom. The derivative of x is 1 times the top, e to the x. And we divide this all by the bottom squared, which is x squared. And once again, if we want, we can take a common e to the x out. If we do that, I have x left here, and I have a -1 there, and on the bottom I have x squared. So that's how we start deriving exponential functions and applying some advanced techniques like product rule and quotient rule, and making sure we understand there's always a chain rule when we derive exponential functions.